So following on from the previous video, we would use this to model our game of golf. So we would use this as our model. And the question was, which ring is it most likely to land in? So it could land here, it could land here, it could land, well, which ring is it most likely to land in? So our normal routine here would be to work out the probability of it landing within this region, and then work out the probability of it landing within this region. So that's this ring here. And then the next step would be us working out the probability of it landing within this. Remember, we're doing segments of 5. So from here to here is 5 meters, from here to here is 5 meters, from here to here is 5 meters, and so on. So our normal routine here would be to work out the probability of it landing within this region. So we would do this. So the probability of it landing within this region is given by this. So when you look at this, the first one will be from 0 to 5. So from 0, so the radius from 0 to 5 is here. We would need to combine the area with the height. So this bit here, hang on, oops. So this volume here, if you like, this bit here is really the volume. It's a combination of the area. It's a combination of the area and the height. So this bit here, you can think of it as being the volume. Okay. So this whole thing here. And then you would divide it by the whole thing. The whole thing meaning from the whole thing meaning from 0 all the way to infinity. And remember, we're revolving it 360 along the y-axis. So you would work out our volume here and then divide it by the whole thing from 0 to infinity. So that would then give us from 0 to 5, and then from 5 to 10. So from 5 to 10, we would need to do this from 5 to 10, and then we would follow the we would follow through the whole process, and then later on we would change it from 10 to 15, and then see which one will have the highest probability. But rather than looking at the probability, let's just look at this bit here, because if you look at the probability, you would get this divided by the whole thing. Well, let's just concentrate on this bit, because we are trying to answer the question of which ring is it most likely to land in. Well, if you look at the probability, if you just consider this bit only, just this bit here, the higher this is, then if this is high, then it would automatically imply that the probability will be high. If this bit here is small, then it would automatically imply that the probability will be low. So just to answer which ring it's most likely to land in, we can just consider, well, which ring will have the highest combination. Well, which ring will have the highest this bit here. Okay, so remember, this bit here is a combination of the area and the height. So hang on. So this bit here, only this bit here, is a combination of the area and the height. So let's just take a random ring. It is this area here. Okay, so hang on. So this bit here is a combination of the area. So that's this area here, and the height. So it's a combination of, so you can think of that as being your volume here. Okay, so think of this as being your volume. Well, the point is that the higher this thing is, then it would automatically imply that the higher the probability would be. So let's just concentrate on this bit here. So work out the volume here from 0 to 5, and then later on work out from 5 to 10. Okay, so as it turns out, if you from 0 to 5, that would then give you this. That would then give you this. That would then give you this number here. So for you to evaluate this, okay, for you to evaluate this bit here, then you would need to do this. So if you integrate this, from 0 to 5, it would give you this. It would give you this. Okay, so evaluate this. It will give you this number here. Remember, this number here represents the area combined with the height. So this ring, this spot here, okay, has a volume of this thing here, and then from 5 to 10, it will have a volume. So remember, this thing here, this number here would represent the volume. This volume here, it would represent it's combining the area with the height. So it represents the volume of this hollow cylinder-like thing, if you like. But it's not perfectly. It's not a perfect cylinder. Well, anyway, this thing here represents the volume of this, and then this thing here represents the volume of this ring here. Okay, and then it's combining it with the height. So the higher the number here, the higher the volume here, it would automatically imply the higher the probability. So if you look at this here, look at this here. It's starting in this region here. It's quite small, and then it gets bigger, and then it gets bigger, and then it gets bigger, and then it gets bigger here, and then it gets smaller. And as it turns out, the further you go, it will get smaller and smaller and smaller. But the point here is that that this ring here, hang on, this ring here. So hang on, this ring here, this ring here. Wait there, bear with me. It's really between. Hang on. It's really between this ring and this ring here. So this ring here is just beyond the 20 mark. Bear with me. So just beyond the 20 here. Okay. So this 119 one is this ring here. Okay. And this ring here is between 15 and 20. So is the inner one. Well, the point is that the highest ring happens to be this one here. Hang on. When you hit a golf ball, it's most likely to land. If you were to use the model that we used, it's most likely to land within this region than it is to land in this region here. And then it's anyway, the most likely ring would be this ring here. Okay, so it happens to be this one here. Okay.